All right, Algebra 1A students, welcome to part 2 of lesson 2.3. In this video, we're going to be solving multi-step equations in the same way that we did in our last video. But we're going to look at a little bit different types of multi-step equations. Okay, we're going to look at a couple different types here of multi-step equations that we have to do something with that equation before we can solve. And the first thing that you might have to do to an equation before you solve it is use the distributive property to get rid of some parentheses. Okay? So here we have an equation that says negative 8 times, in parentheses, 2x minus 1. All of that equals 36. So on the left side we see parentheses with a 2x minus 1 inside and a negative 8 in front. That's a situation where we want to use the distributive property. Right? We want to multiply each piece in the parentheses by the number that's outside the parentheses. Okay? So obviously the first part would be negative 8 times the 2x. Negative 8 times 2x is negative 16 with an x. And then negative 8 times a minus 1. Negative 8 times minus 1. Negative times negative makes plus, positive, and 8 times 1 is 8. Okay, so the left side becomes this, negative 16x plus 8. It is still equal to 36. Okay, and now we can solve this equation by doing the same two steps that we would normally do to solve a two-step equation. The first thing that I want to undo is this plus 8. So I will subtract 8 from both sides, cancel that out over here, minus 8 from this side as well. And I end up with an equation that says negative 16x equals 36 minus 8 is 28. Okay. And then to get x by itself, all I have to do is divide both sides by the number attached to my x, which is a negative 16. So cancel that out. And divide this side also by negative 16. 28 divided by negative 16 leaves me with x equals negative 1.75, which you could find on a calculator if you have to. Okay? But after we do the distributive property, it's just a normal two-step equation where we undo the multiply, then we undo the addition first, then undo the multiplication. Okay? Let's take a look at this example. I'd like you to try this one, where I give you 18 equals 3 times, in parentheses, 2x minus 6. So the first thing you need to do is do the distributive property, and then solve for x by undoing the subtraction, undoing the multiplication. Pause the video for a couple of seconds, a couple minutes, take a look at that problem, then come on back when you have an answer for x, a solution for x, and I'll show you what we should get. Okay, in this case, we should end up with 6x is equal to 18 plus 18, which is 36, which means x equals 6. Okay, x equals 6. So that's one type of multi-step equation we may have to solve, which would be using the distributive property before we solve. The other type of equation we may see in our practice problems, or you will see in your practice problems, is this. Fractions. Okay? Equations that involve fractions. Now, in order to deal with an equation that has fractions in it, what we are going to do is try to eliminate all of those fractions right away as quickly as we possibly can. Okay, so the first thing that I want to do when I'm solving an equation that contains fractions, step 1 here, is going to be find the common denominator for all of those fractions. Okay, step 1 is find the common denominator for your fractions. In this equation, I have 3x over 4 minus x over 3 equals 10. So the two numbers on the bottom of my fraction would be the 4 here and the 3 here. So the common denominator for 4 and 3 is going to be 12. Okay, so once I find that common denominator, step 2 then here is to multiply everything by that common denominator. Okay, I'm going to multiply everything by that common denominator. And I mean everything. Okay, everything in my original equation gets multiplied by this common denominator of 12. So I'm going to put everything in parentheses, put a big 12 out here, and then I'm going to multiply every single piece of my equation by the common denominator 12. Okay? Now, I'm going to make it be 12 over 1, and I'm going to make the 10 into a fraction as well, just so that our life is a little bit easier multiplying these fractions. So what I need to realize is that first piece, 3x over 4 times 12 over 1. Well, 3x times 12 on the top will be 36x. And then the bottom of that fraction is going to be 4 times 1, which is just going to be 4. So there's my first fraction, 36x over 4. My next fraction is x times 12 on the top, which is going to be a 12x. The bottom is 3 times 1, which is a 3. And there is a minus sign in between these two. And then after my equal sign, I still have to deal with that 10. Now the bottom of those two fractions on the end, right here, this one and this one, both of the bottoms are 1. So when I go down here to my answer fraction, the bottom of that fraction can be a 1. Oops, I got a little bit big. Right? And on top, I have 12 times 10. Right? I'm doing 10 times 12 over 1 times 1. I get 120. And obviously that's on the other side of my equal sign. Okay, so I end up with this equation now. 36x over 4 minus 12x over 3 equals 120 over 1. Now what I need you to realize is that all of these fractions can be simplified down. Right? 36x over 4. 36 divided by 4 is actually 9. So this is going to become 9x over 1. This next fraction, 12x over 3, is going to become, well, 12 divided by 3 is 4. 3 divided by 3 is 1, so it's 4x over 1. And then the last fraction, well, obviously that can't be reduced at all. It's just 120 over 1. Okay? So I have a minus sign in between these two, and then I have an equal sign in between those two. Now, what you have to realize now is when I get to this point in solving, I have all of these fractions with a 1 on the bottom, but I don't really need the ones on the bottom, right? A 1 on the bottom of a fraction doesn't need to be there. It can be deleted. So none of these need to be fractions anymore. It can just say 9x minus 4x equals 120. Now this is something I can solve. Okay, now this is something I can solve. 9x minus 4x is going to be 5x's. It is still going to be equal to 120. So 5x equals 120, and then to solve that, I'm just going to divide both sides by 5. And I get that x is equal to 24. Okay? So I have these two steps to turn this equation into something that I can solve. I'm trying to get it to be this thing, right? 9x minus 4x equals 120. I do that by multiplying everything by the common denominator of the fractions. Okay? Let's look at one more example here. Let's look at this letter A right here, where it says 2b over 5 plus 3b over 4 equals 3. And what I want you to notice is the common denominator of these two fractions, the 5 and the 4, is going to be a 20. So I'm going to take this whole equation and times everything here by a 20. Okay? A 20 over 1. I'll put that over 1. What this ends up being when I distribute that 20 to every piece, to the 2b, the 3b, and the 3, it ends up being 40b over the 5. The next fraction ends up as 20 times 3b is 60b over 4 on the bottom. And then the last fraction is 3 times 20, which is 60, over 1 times 1, which is 1. Okay, so equal sign here, minus sign there. And now I can simplify those fractions. 40b over 5, 40 divided by 5 is 8. The bottom of the fraction goes away. 60b over 4, 60 divided by 4 is 15b. The bottom of that fraction also goes away. And then 60 over 1 is already a pretty simple fraction. I can just drop the 1 on the bottom and have it be 60. So now I have 8b minus 15b equals 60. Well, 8b minus 15b equals 60. 8b minus 15b would be a negative 7b. So negative 7b equals 60. And then I solve by dividing both sides by negative 7. And I get that b is equal to negative 8.6. I'm okay with you rounding off to 1 decimal here in this case. B equals negative 8.6. Okay? So again, I'm just multiplying everything in my equation by the common denominator, and then solving for the variable once I get it to something without fractions. Our goal here is to get it to be an equation without any fractions. Okay? Let's see. We'll skip letter B for now. We'll just let you do some practice when you get to class tomorrow. If you have questions about any of this, please make a note to ask me in class tomorrow before you start your practice problems. Otherwise, that's all I have for you. Have a wonderful night.